Welcome to Ontology 101. As you know, we're doing our 6 week cycle. And we are at the end of the 6 week cycle. First 2 weeks, of course, focused on solicitation of requirements or competency questions from stakeholders, people who might be enlisting you to build an ontology or knowledge representation structure. Following two sessions are devoted in this cycle to the construction of design patterns, sort of like visual representations of the sorts of structure you would need to answer the questions that stakeholders want answered. And then now the last two sequence, or the last pair of sessions here, and to end the cycle, two sessions on converting those design patterns into OWL. So OWL, or RDF format. OWL, of course, being the web ontology language used across a lot of ontology projects. It's a sort of description logic-y language, has some formal representations in it. We talked last time about what it means a little bit at a high level, about some of the logic involved in OWL, sort of like disjointness constraints you might put between classes. We have brought up BFO, or at least I brought up BFO, or the core version of it, in Protégé, and we started dropping some classes and subclasses under it just to kind of get a feel for the air flight. Was it air flight optimization, air flight maintenance? Yeah, stuff like that. Yeah. And today we're going to pick that back up and continue our modeling, actually from a fresh plate. So I'm going to share my screen here, and you should be able to see Protégé in your face. Is that right? You guys see it?
Yes.
Okay, very good. So last time I left a bit of a wide berth for conversation. So we had, some design pattern representations. It was an Excel file, I believe. But there was actually some visualizations. And we're essentially just picking, like taking pieces out of that and then having a conversation about what to put where. Today, I would like to speed run it a little bit. And so in the interest of doing so, I was thinking this would be less of a question answer kind of conversation and more of a how do you do it? And so with that in mind, I've got Protégé right up here. We've got BFO core right up here. I was hoping somebody would just start telling me what's in the diagram. That visual diagram, the design pattern, and I'll just start placing it where it needs to go. Perfect. Am I remembering correctly? There was like a diagram. Yeah. Do you have the diagram by chance?
Yeah. It's inbound. Hold on.
Got it. Thanks. All right, here we go. Perfect. Axioms of flight. You guys see the visualization as well? So you can see that. It's right beside my Protégé instance. All right, so here's what I'm going to do. Um, Again, instead of like conversing, I'm essentially just going to start building. And what I'm going to do is read it right off of the diagram. I don't want to assume, like you shouldn't assume that everything I start mapping off of this diagram is accurate, 100% accurate. I mean, it will be accurate to the diagram once, but I want you to see what I'm doing and like see me walk through this. And I will try to talk my way through it as well. So I'm gonna start with a node, one that has some things hanging off of it and things that aren't. So flight capability. I'm gonna assume, think this is reasonable, that this is a realizable entity. As a matter of fact, it's a type of disposition, because we don't have capability proper in here. I'm just going to put flight capability here. Uh, if you're in the know, there's a capability class that sits between disposition and function, just hasn't been updated or added into BFO, although it's likely to go into CCO. So what do we have? I have flight capability has continuate part. It's related to propulsion capability. Observe propulsion. Oops. Propulsion. Is that right? Capability. Okay. I know nothing other than these are both capabilities. So I'm not going to suggest that one's a subclass of another. Lift capability. And while I'm doing this, I want you to think. I want you to watch what I'm doing and hear my reasoning about the decisions I'm making and kind of imbibe them. You'll see that I'm like trying to say as much as I can about what's in the diagram, but try my best not to say anything false. So that example I just described was a good one. So I see lift capability, propulsion capability, flight capability. I have no idea based on this diagram whether they're subclasses of one another or not. And so I'm just going to make them siblings because they're, I'm placing capabilities under dispositions here. It may be the case that there is some kind of subclassing relationship across these. If that is the case, when you're building a diagram, you shouldn't say that. You should make that clearer if it's not. And then, what goes for capability goes for other things. Um, all right, so I will do the same here. Attitude, attitude control, capability. Okay, now got those capability classes. And I'm seeing has continuate part. So flight capability has continuate part, all of these. So now I'm going to pop this open here. And I'm going to add subclass constraint on flight capability. So it's got three things hanging off of it. Has continuum some. I'm going to assume that it's some propulsion capability, some lift capability, some attitude control capability. Why? Well, you gotta when you're creating a subclass constraint, when you're putting an axiom, you're gonna have to pick a logical connector. So this is a relationship and it's relating an instance of flight capability, any instance of flight capability into in some description of an instance. It could be all instances, it could be only, or it could be only instances. It could be exactly a certain number of instances in this other class, or it could be just any, like some instance. The weakest is going to be saying that it has continuate parts. Some, for example, propulsion capability. I'm saying I'm focusing on the weakest way of representing this because I don't know anything stronger. All I know is it has continuate part, at a minimum something. You could mean that it has exactly one propulsion capability. You could write that by saying this. Exactly one propulsion capability. Exactly two propulsion capability. You could say it has it has continuate part only propulsion capabilities, right? In fact, let me show you some of the logical differences here. So I'm going to put has continuate part only propulsion capability, has continuate part only lift capability. Now I'm going to run a reasoner and see what happens. Did anything happen? Let me throw in an individual here. I'm going to say lift.
Are the classes disjoint?
They are not.
Okay.
What I'm going to do here, so I'm going to drop this under, oh no, rerun. And I'm going to make them disjoint. Well, that didn't do what I expected it to do. So maybe I won't illustrate the logical difference here because I'm clearly reading this wrong. In any event, did I put that? So it should be the case you have any flight capability has continuous part only lift capability and has continuous part only propulsion capability. So if I were to say, oh, I know what it, okay. Let's see. Object property. Wait, what did I say? Continue part of flight capability. There we go. Oops. Oh yeah, that's right. Gotta add that. Let me try that again. Mm, mm. All right, I got an inconsistency. And it's so bad, as a matter of fact, that it won't actually tell me what happened. I'm going to see if I can run with a different reasoner to see if it will give me more information. Ah, okay. So you see, just to illustrate, I'd had pellet and I ran my reasoner and pellet just said, I can't do it. I've got like an inconsistency with the disjointness. There's like a suggestion about that. So stop the reasoner. I jumped over here to Hermit. Start that reasoner. Inconsistent, blah, 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 blah. Now, Hermit will give you some reasons. Try to explain. So lift capability is a lift capability, the instance of, continuant part of. There's an inverse relationship. So I asserted has continuant part, or I asserted the inverse of lift capability. So flight capability is type of flight capability subclass of has continuant part only, propulsion capability. Propulsion capability is disjoint with lift capability is continuant part of flight capability. So generated inconsistency with that. Now, let me show you if I were to stop this reasoner, adjust this, say sum, and then adjust this to say sum, start my reasoner again. No inconsistency, reasoner ran. I've got an inference about flight capability, namely where I'd said lift capability is continuant part of flight capability because these are inverses has continuant part lift capability. So again, there's just the illustration here was on the logical strength of only versus some. Only is stronger. You can generate an inconsistency. Whereas if you were to use some in this case, you're just picking out some, not necessarily all. And so there is no inconsistency there. Yeah. Yeah, Sam.
Yeah, can you clarify I'm looking at the flight capability in your screen right now.
Mhm.
You used an object property with a restriction and then to a class, but it's underneath subclass of, but you have not subclass lift capability underneath flight capability. I'm just wondering how that works. That's a bit confusing.
Yeah. Yeah. So in the OWL semantics, all of the object properties that you can describe, like the continuant part of anything that's listed as an object property, is like they have They look in the editor, they look even in the abstract syntax as class to class relationships. And so you're linking like a class of things. It looks like, abstractly, you're looking like a flight capability class through this object property to lift capability class. But what it's actually saying, if you like, when you dig into the underlying semantics, is any instance of the type flight capability is related through has continuum part to some instance of the class lift capability. And so they talk about this in terms of subclasses or subclass relationships. It's kind of like, indirect way of speaking about the members of the classes or the instances of the classes and how they relate. And there's always this, no matter what you're doing on the subclass side, like in fact, that's what it means. Subclass, you're always in putting before the expression that you write, all, right? So this is technically read as like all instances of flight capability has continuate part some instance of lift capability. And same for all flight instance of flight capability has continuate part some propulsion capability. Does that make sense?
Yes, that makes sense. It helps clarify it.
Awesome.
Just the subclass,
Yeah,
the IDE showing a subclass was what was confusing. Got it. Thank you.
yeah, yeah. Yeah, it does take a little getting used to. I'm gonna go ahead and put
John,
this.
did this commit us to rock? If I pick up a rock and I throw it through the air, that is by definition not a flight. It's propelling through the air,
Mhm.
but the rock can't propel it. It doesn't have a propulsion capability, a lift capability, or an
Right.
attitude control capability. Therefore, it's not really flying.
Yeah, and this would, I mean, that would be outside the scope. So you wouldn't call it flight capability. You wouldn't say like the rock had a flight capability in that sense.
Right.
And I think that's what I would be inclined to say. Now, maybe in
Yeah.
natural language of some folks who are like, this rock can fly and it's got some disposition to fly or maybe capability. And if that is the case and they feel strongly about it and it could articulate, the capability in a clear way. I mean, I'm not one to
Yeah.
go correct, but that wouldn't be what we're talking about. That'd be a different flight
Thing.
capability.
Yeah.
Yeah, and maybe we'd even disambiguate by saying something like, you know, like aircraft flight capability, something like that.
Right.
Yeah.
Right.
All right. So I've got flight capability and links here. Now we need some material object that has this capability that a controlled flight is participating in. So again, I'm just kind of moving through. Now, where would I go next? I'm gonna assume the controlled flight is a type of process because it occurs at some site, it occupies a temporal region. So I'm going to drop it down here. Controlled flight. Again, I don't know based on the diagram what if there's anything more specific. So what I'm going to do is just read off what I can, and I know it's going to occupy some temporal region. Excuse me. It's going to, and I can assert that here. What is that? Oh, it's lowercase. And I'm just going to go and check. So I just clicked on occupies temporal region. Incidentally, I should do the same for the other. I'm click over here. And what do I see? So occupies temporal region. Its domain is process or process boundary. So either like an extended process like baking a cake or a boundary of it, like the start and the end. And those are different classes in BFO. You see process here and then process boundary right below it. Now I'm checking on the domain and range because if I say what this occupies temporal region relationship between a process and like a spatiotemporal region, I will get an inconsistency. So I always want to check that I've got the right domain and range. In fact, I didn't do it here for the capabilities, the flight capability, but it's good practice. And so the relationship I'm asserting is has continuate part I want to check that. What's the domain and range? Continuate to a continuate. Okay, so that's not problematic. And you can always check, of course, but yeah, I think it's good to keep in mind domain and ranges. Now, what I'm doing here, just to be clear, as I'm reading off of this diagram, class level constraints. So this says, strictly speaking, um, every instance of controlled flight occupies some temporal region. Now, I don't think that's false, but you should be careful when you're thinking about this or thinking about capabilities or propulsions like this, like flight capabilities, for instance, should be thinking, okay, is this diagram reflecting something about all flight capabilities, or is it reflecting something about a specific flight capability? Like that may have different sorts of continuum parts than all of the flight capability or instances out there. And so you should always be thinking, am I talking about the classes or am I talking about the instances? Now here, I'm assuming that I'm talking about, or that we were talking about the classes. That may be mistaken. And if so, as I worm my way through the diagram, it'll become clear because we'll end up asserting something that just doesn't apply, like something at a class level that doesn't really apply to all of the classes or the instances of a class. And so in which case I need to go back and start like putting a lot of the classes I'm building over here, or at least the constraints that is, over on the instances. But until I get there, I'm going to try to do the class level, unless corrected otherwise. And don't correct me, I want to find it out if it's true. So controlled flight occurs at, I'm going to drop another subclass relationship. It occurs at, right now I don't have occurs at here. Let's see what I do have. Occurs in, and occurs in relates a process to a site or material bound or entity. So I'm gonna update this. I'm gonna put occurs in instead. Some in that weakest I can. Now I've added a couple of things. I'm just gonna synchronize the reasoner. So far, so good. So no inconsistencies. I'm not violated any domain and range constraints, anything like that. Now, controlled flight has participants some material entity. So I'm going to assert as well. What'd you do that for? Oh, it's because I'll just note sometimes when you have the reasoner running and you start clicking around in the GUI, it can act a little funky. It'll start like flipping you around on different screens. You just might want to turn it off as participant. If I'm so as I'm typing, I see there's like something that went up in the chat. If you want to ask a question, you feel free. While
No,
I'm
yeah,
oh,
John, I tweaked that graphic just slightly.
got it.
That one box was missing its arrow.
Got it. Okay.
So,
That's material.
and just a conversation on while you're doing that. So you see where that controlled flight, this was an actual conversation that we had it in the aerospace industry where all the one group cared about was, hey, I just need to know where the flights are. I don't, I just
Right.
need to know that there was a flight. That then turned into, no, I need to know the phases of flight. That was another person that came into the meeting. So
Nice.
then that was like, oh, okay, well, we care about acceleration, takeoff, ascent, cruise. In other words, some of the experts didn't care about those things, but then you have someone in the meeting who's like, oh, I know, I absolutely care about that. So, and that's how these conversations expand the ontology a lot of
That's
times.
exactly right. And that's how we kind of expand and like represent the logical space of alternatives. Like we
Right.
describe in a consistent, coherent way what the stakeholders need as they come and change and update. But yeah, very good point. So I'll note, I'll say I have controlled flight. It has a participant, some material entity. So I'm right here in the diagram and I'm looking at, now I know this is material object. I'm just going to assume that we mean material entity. But one thing I'll note, this is where we're going to get into the class versus instance thing. So it would be it would be incorrect to say that every instance of material object slash entity has capability, some flight capability. this is sometimes it's like observing this is sometimes called the all sum rule. So when you're pointing your arrows at the class level, you have to think all sum. Is this true? That said, I can slightly tweak this, and you often can, to get
Yeah.
around it and still respect that this is about classes. And so what I'm going to do is I'm going to actually, instead of going to, material entity and placing a constraint there, what I'm going to do instead is I'm going to go back to flight capability, and I'm going to invert this. And so I'll say something like capability of material. So every flight capability is a capability of some material entity. Now, I will note that there isn't a capability of relationship in BFO. And so there's something like this in CCO, but I don't have that with me. So for the sake of illustration, I'm going to put something here now, just add something in. So I'm going to go to in here's in. So this is a relationship between specifically dependent continuance and independent continuance. So like specifically dependent continuance being the parent class of things like realizables, like capabilities, dispositions. And so this is going to link, a capability to some material object or some independent continuum material objects falling under those. And so I'm going to introduce a subproperty here, and I'm going to call it capability of. And I'm going to assert, hopefully you can see this. I'm going to assert that it has a domain uh, capability, or I didn't give it a parent. I didn't give it like a general class. So like capabilities where all the capabilities fell under. So what I'm going to do instead is I'm just going to stick it with specifically, dispositions, because it's the highest, because this is the highest parent that all of these capabilities have in common. So I'm going to say that, and this is going to link to, for us, I'm going to put in, let's see, just for the sake of illustration here, I'm going to restrict it to material entities. Okay. So now I got domain and range restrictions. I can also introduce has capability inverse. I'm not going to, but I will just pause here instead and reflect. What is there anything that I can say about the characteristics of this property? Now in BFO, you're not going to see. You'll see some of these like preceded by as transitive. Think something like occupies spatiotemporal region is functional. Functional means if like X is related to Y and X is related to Z, then Y and Z are the same thing. So it's a way to like collapse and make an order. So I'm thinking here though in terms of capability. I know it's probably not functional, probably not inverse functional, it's probably not transitive. So transitivity is if X is related to Y and Y is related to Z, then X is related to Z. So that would be like if X is capability of like Y and Y's capability of Z, the next capability of Z. That's just not true. Symmetry can't be true because these have different domains and ranges. So, and they're disjoint. We might say something like it's asymmetric. So it is not the case if X is a capability of Y, then Y is a capability of X. That seems correct. We might also say that it's not reflexive. Nothing is a capability of itself, we might assert. Let's check.
So a question on that. So given that the domain and the range are already different, is it necessary to do that, or is this just for pedagogical purposes that you're
Pedagogical purpose. It is for pedagogical purposes. Now I am because this would be entailed, but instead of actually just saying that, here's what I'll do. I'll show you. And I'll show you how to test. So I've got capability of, I'm gonna drop in X, I'm gonna drop in Y, just for giggles. I'm gonna say um, X is capability of Y. Actually, I'm gonna say just to check the reflexivity, I'm gonna say X is capability of X. So just introduce this instance, and I've asserted capability of. Now I said it's I was asserting that it was irreflexive. So nothing's capability of itself. And I've just removed that. But I've also maintained the domain and range restriction. So check. Boom. Inconsistent. So you're absolutely right. And what it's gonna result in is a proof about that has something to do with it. Well, yeah, it's because it's running up the chain of disjointnesses, but you're gonna see disjointness pop up in all of these. And in fact, one of the beautiful things about the reasoner or the Hermit style reasoning is you can see what justification appears in all of the proofs. And you'll note disjoint appears in all of the proofs. So your reasoning is spot on. There's just multiple ways of getting there. Now I'll also try the other way around, right? So capability of X, I'm going to drop that and say capability of Y. And then I'm going to say Y capability of X. Check that out. Stop reasoner, try again. Boom. Explain. You're going to find the same results. I'll just pause it right there. All, we can see that, all disjointness. So let me get rid of those. So again, to answer your question, so not strictly necessary to assert the irreflexivity or asymmetry for pedagogical purposes, for sure. If I were to drop the domain and range here, and I wanted to like rule out those sorts of cases, I would need to assert the characteristics here. Now, given that, not a lot of harm in doing so. I've just gotten rid of those problematic instances. So nothing problematic there. It just gives the machinery working in the background as it's sorting through the tree. It just gives us more information that it could use to sort out or remove certain branches from the tableau. And so I like to include them. I like precise representations myself, but and I like to make things as explicit as I can. So okay, I'm now back to capability of, so, and what I want to do is assert flight capability. Any instance of that is capability of some material object. And so I've got back over here to flight capability. And now I'm going to go back to this expression editor. Actually, you know what? Since I've just been typing in this class expression editor, but I do want you to see, you can just kind of scroll down through the hierarchy. I don't like doing this myself because it can be a bit cumbersome to like find what I was playing with or what I introduced. Now this one's pretty easy. So I pick for example, the object restriction creator. I'm picking the capability of, and now I'm going to scroll down or open this up and go to material entity, and then introduce that. And you'll see capability of some material entity. I'll just check my reasoner. Everything's kosher. We're good. And so again, inverted this relationship. And now I'm just going to continue moving down the diagram. So what do I have here? I've got this occupies some temporal region, occurs at some site, site occupies spatial region, 3D region. Now, I think this is in general true. Sites occupy spatial region, three-dimensional spatial region. So I'm going to, I don't need to. Already in there. Occupy spatial region. In fact, they only occupy three-dimensional spatial region. I'm going to read it that way because it's right in line and it's strong. It doesn't exactly entail that there is some three-dimensional spatial region, but it does entail that anytime there is a site that's occupying a spatial region, it can only occupy three-dimensional spatial region. So I'm gonna view it that way. Yeah, go ahead and talk or ask a question if you have one.
What would be an example of a one-dimensional spatial region?
Oh, great point or great question. So we have right here, one-dimensional spatial regions. They are the edge of a cube-shaped portion of space or a line connecting two points or two parallel lines extended in space. But one-dimensional spatial regions are essentially, as you see here, spatial regions that consist of a line together with zero or more lines that may have points as parts. There is some confusion often over spatial regions and boundaries. So you see one-dimensional spatial region, flat line, like when do I use what? I encourage you, insist in fact, to always use the boundaries because the spatial regions are actually part of the theory of BFO that like tie the occurrent and the continuous sides together under spatiotemporal regions. But lines and sites are the sorts of things that are in space and time. They're like embedded there. Sites move through spatial regions. Lines move through spatial regions and so forth and so on. So I typically encourage people to stick with lines like this class and subclass hierarchy here rather than the spatial region stuff. There are other reasons too. I've given a couple of talks on this I can direct you to about like some of the problems with using spatial regions and like historically and the confusions that have arisen. Typically, they'll say don't use these, use these. Your question still stands though, like because you want to be able to give examples for that too. I think, you know, line boundaries, like a property boundary, right? A property line. But really, like in if you're thinking about this a little more theoretically, I like to think about this as like the relationships here is if you have, say, two three-dimensional sites where they meet, you get a plane, and where two planes meet, you get a line, and where two lines meet, you get a point. So you can like move through abstractly the kind of immaterial entities based on reduction of a dimension insofar as where they meet. I know it was a little too much information, but hopefully, in passing, answered your question about an example for spatial region.
Yes, thank you.
Right, very good. So, okay, so we have occupies temporal region. Now, I do know occupies temporal region um, is already looked up here. So we've got temporal region. I don't need to do anything else there. So I'm going to pop over now and move up. So controlled flight has a current part, some cruise. So I'm assuming that cruise here is a process, right? And so I, again, don't know too much about subclassing or anything here, so I'm just going to put cruise as a type of process. And I see that it's going to proceed. I'm going to move this over. It's going to proceed and an ascent and descent, which I remember discussing. So I already know I'm going to need to go ahead and put in some more processes. So I'm going to put in ascent here, and I'm going to create another sibling, descent. And what else? It looks like there's a land, so I can just kind of knock a lot of these out and start asserting relationships across among them. So I've also got takeoff, right? And accelerate. Oops. Accelerate. And we've got a bunch of a current part of, or has a current part and precedes relationships. All right, so here's what I'm going to do now. So again, I'm assuming that this is operating at the class level, and I think for most of these, that's going to be straightforward. But I have a sinking suspicion that we may come into some difficulties with respect to the precedents. But let's work through it and see. So I'm just going to start asserting, just following the chain. So control flight. I'm going to pop back over here as a current part, some cruise. I'm going to copy that because I know I'm going to be writing the start of it a couple of times more. And then cruise, pop over to cruise. Let's say that has a current part. Does it have a current part? Oops, sorry. Drop that out. Proceeds some, cruise proceeds some descent. Okay. And then descent precedes some land. Now I'm also noting precedes some land, and then I'm going to assume that all of these that controlled flight has all of these as occurrent parts, and that's what's going on there. I think that seems plausible, so I'm just gonna do that. I can actually just do it all here in one assertion. What is it? Ascent and land and descent. Land and take off and accelerate. Boom. All right, so that takes care of the current parts. And let's see, what do I got? Where did I land? I got proceeds. So descent proceeds some land. I don't see anything popping off of land. So I think I've gotten everything over there, but I do see ascent proceeds. And look, it's auto-populating. So we'll type in that and then takeoff. Do the same, proceeds, some ascent, and then accelerate, proceed, some takeoff. Good.
Hey, so what would this look like in ontograph? Or are we not? Is that jumping ahead too much?
So let's see. Dun, dun, dun. Did I do that right? So accelerate, proceed, some takeoff. Okay, and hopefully I've done this correctly. So I think if I'm reading these tea leaves correctly, I have constructed the design pattern. Let me check. I don't think I let any inconsistencies. So it looks like this ran. Running reasoner. Didn't take long. Computing inferences. Okay. All right. Now, we have been asked to check this out and onto one of the viewers. Let's pull it. Oops. Pull it up. Ontology viewers. Let's see, where is this ontograph? Is it this one? Ontograph import view? Or is it the
Where is ontograph? Yeah, you gotta find it.
here, I want to pull up a window actually.
It's a tab. If you go to Windows and you go to tabs, it's down
Yeah, I got you.
about halfway down on
Okay.
tabs.
All right, here's what I'm gonna go to controlled flight because that's kind of the centerpiece of this whole bad boy. I'm gonna expand it off. Now I'm gonna expand this, expand this, expand this. Oops, I didn't want to do that.
What hotkey are you using to expand?
Oh, I'm just double clicking.
Oh, okay.
Yeah. Let's see. Let me click at this. So I want to just, there we go. I don't want to expand temporal region. It's going to have a bunch of stuff in there I don't want. I'm going to want to expand accelerate because I'm just going to want to see the relationships it has. Descent, ascent, cruise. Let's see. And I also want to expand the capabilities. I know those are going to be important. So there was the big one, the kind of other core here was flight capability. So I want to expand that. Don't hide. We're all friends. Come play. So basically all of the links that I've asserted directly are the ones that I'm gonna expand out here. Oof, that's a beast. Let me try something else. Nah, man, that doesn't look great. It's trying, right? Uh, all right. Now I can turn off some of these arrows. Let's see. So I'm gonna drop some of the exist at. Some of the stuff that I didn't really add. So instant of has last instant. I did add some of that. I'd added one participant. Didn't add that. I did add that. Occurs in temporal product. Don't need that. Temporal projects on. I'm gonna drop these instances. Uh, but I'll leave the rest. No, what do I? I'm going to drop the instances in general. We'll see if I can clean this up a little bit. Hmm. It's trying. It's trying. And typically, if you're using the viewer, you'll probably want to clean it up a little bit, honestly, just to get a better picture. Maybe that's the best way. Although some of the items here are missing. So, all right, if you hover over here, you can see. So this is, we can actually see what the relationships are being asserted. So these are participate or a current part of relationships right there. And so that should track. You've got these a current part of control, or I'm sorry, it's has a current part. So controlled flight has these occurrent parts. If you wanted, you could, pull them up, make it clear, although note the webbing that's going to happen. If I were building this, I would probably put some of these items like um, temporal region out of the picture for a minute. Also, I'd probably move this over here just because I know it has a bunch of stuff on it that I didn't exactly add. Um, but yeah, it's a little bit of a mess. You can, if you wanted to say, just focus on um, the, yeah, I don't need those. You just wanted to focus on, say, the precedence relationships. Where's that? Seeds. Is that even in here? You can check this. So takeoff proceeds. There's still going to be like the subclassing going on. I could get rid of those, I suppose, if I wanted to. So now what you should be seeing is just the precedence relationship. So if I wanted to see if I'd gotten these correct, I might move some of these out of the way. Put the ordering in place, like proceeds, got the cruise over here, proceeds there, then take off. Yeah. Now, if I wanted to say, observe that, but also build out what was it, a current part of, or has a current part relationship? Where was that? Has a current part. Now I can see a little more cleanly the relationship between controlled flight and these sub occurrence, or these proper recurrent parts, presumably that are preceding one another. Now I did say that at the beginning I was like, maybe we'll run into some of this class instance, or some of those class instance concerns here. And what I had in mind specifically was that for controlled flight, it seems there may be some wiggle room around whether, I think this came up last time, whether it is the case that it always starts with accelerating, then a takeoff, and runs to ascent, and then cruise, and then descent, and then landing. If it was the case that always happened for controlled flight, I think one of the examples that came up as potentially worrisome for this characterization is you might put a plane on a plane and fly one plane out and then drop the other plane out, at which point it would not be taking off, or it would likely be accelerating, but wouldn't be taking off, would be kind of dropped out, wouldn't be ascending. One of these at least might not be in place. There are a couple of ways to address that. You could rely on that, and I think John mentioned this last time. You say, look, for a controlled flight, we're just saying some of this happens, right? There, like there was some acceleration, some takeoff, some ascent. We didn't indicate which plane in this combo plane carrying situation is doing all parts. I don't know that that would be the intended reading of this, but that's a legitimate counter. But another way of addressing this is you might want to say, well, look, these are actually not class constraints for all controlled flights. There instead, we're talking about specific controlled flights. Some
Yeah.
control, maybe it is the case that all controlled flights have some of these, and we would stick with those. But maybe like for a specific subset of those of control flights, they actually do have all of these, and we can like we can tease that out by creating, say, if we wanted, by creating a subclass of controlled flight that really just captures those controlled flights that had all of these features in common, but may only have some of these features in precedence that apply to all controlled flights in general. So with that, I'm going to stop. We got a couple of minutes. Want to make sure you guys have time for questions. But yeah, any questions? Hopefully that's
John, could
yeah.
adding the mention of controlled ascent, controlled descent, and controlled landing add to the situation? Because you're sort of saying like, you know,
Yeah. I think that was the intent, and certainly would want to include that in a label. That would just for if anything for disambiguation. And I typically have a practice like that where I'm like controlled flight. This would be like in a controlled flight acceleration, controlled flight takeoff, controlled flight landing. And then what
Yeah.
happens is if I then learn that, all controlled flights or all flights or something. If I learn that all flights have what I'm calling controlled flight ascent as a feature of them, that's something I will learn through the reasoners. And then I will be like, oh, I've given this too restrictive of a label. But I want to learn that from a careful
Hey,
description.
John.
Yeah.
John, so and actually Jeremy brought this up a couple weeks ago. Like, what if you have three organizations in your meeting, in your subject matter expert meetings, and
Mhm.
all three of them say, well, we call landing something different. We call it controlled landing process. We just call it landing, and we call it, something else.
Mhm.
Um,
Yeah.
what about alternate labels? Is that
Absolutely. We can use alternate
okay?
labels. This then gets them on the hook, and I try to put them on the hook for describing exactly what they're talking about. And then not just that, but then describing it in a way that is distinct, if they can, from what the other groups are describing. And this is, I mean, and it's never my approach is never to like which one of you is right, the situation. It's more like I need to know as carefully as I can what you're talking about because I need to know if it is the same thing that this other group is saying. Because if it is, then I'm going to introduce alternative labels. But if not, I want to keep those separate because I'm not in the business of telling one of you who's you're right and wrong. I'll let the logic do that. But so then you need to tell me exactly what you mean. And I'd ask them really pointed questions. I'd ask them questions about like what precedence goes on in every case. Like I'd kind of get a little not technical, but I'd ask them kind of like edge questions about the scenario, and then I'd use what other groups were saying about their understanding of ascent or landing, and then I'd start letting that inform questions that I ask the other groups, just so I can see where I can get like, okay, what's common across this? Yeah, John.
Yeah, I was just sort of wondering what are the next steps that we should take now that this cycle is finished.
Yes, great question. So next steps for the cycle, we will be repeating the cycle. So starting next session. So we'll start off with solicitation again, and we'll work through it. So it is just a 6 week cycle. If you are feeling, ready to move on, we are planning on kicking off a more advanced session, 6 week cycle called 201, roughly speaking, which it hasn't started, but and I'm going to be going on paternity leave pretty soon, so I won't be able to start it for a few months. But in the interim, there are several other working groups that are meeting regularly, some about around building design patterns with Common Core. So Giacomo is running that group with several graduate students. And then you are also welcome to join in on any of the classes that Barry and I are teaching. We put this all online, all of our videos, all of our lectures, and so you could just kind of come and hang out in our Zoom sessions when we're teaching, and see some of familiar faces because some folks here show up to those as well. And that will kind of give you a bit more education. On different aspects and different skills. Some of the classes are going to have less hands-on training than you see here. Some I'm just going to throw you into the wolves and be like, good luck. But you'll be with a group of people that can help you. But when I'm back from paternity leave, unless I find somebody to start 201 in the interim. Then we'll have a 201 session in earnest. And I'll probably have somebody run this group a little more, and then I'll jump over to the 201. And then that group will be focusing still on some of the conceptual modeling just to solidify it, but mostly on like validation, querying, shackle constraints, and actually using the reasoners with OWL to pull out some interesting information.
Okay, perfect. Thank you.
Absolutely. All right. Well, we are 2 minutes past. Hopefully this was informative. Yeah, if you have any questions, please reach out. I'll drop this file into the Slack so you guys have access to it and you can kind of tinker with it if you want, or like run reasoners, test it out, play with it. And with that, like I said, next session we'll be doing the cycle again. So you're welcome to come stay and get like further solidify the material. But in any event, yeah, great to see you.
All right.
Thanks. This is
Thanks, John.
helpful. Have a good one.
Great.
Thanks, John.
Thanks, guys. I'm gonna take off.